In this video, we'll look at solving using compound angle formulae. And you're going to need a formula sheet, so make sure you've got one. I got one here. Well, there's 4 questions, but the first 3 are really short. The first one says, what's the sine of a plus 2a? You could, of course, just combine them and say that's the sine of 3a, done. But what this is really just getting you to do is expand using the compound angle formula. So you bring out your formula sheet, and you take a look. Sine of something plus something is the sine of the first thing, cos of the second thing, plus cos of the first thing, and then sine of the second thing. So let's fill that in here. So sine of a plus b is sine of a, so sine of this, and I'll need some space here, sine of the first thing, cos of the second thing, plus cos of the first thing, sine of the second thing. So that was just a quick practice one to see. You can use this equation using this formula and just expand it. Sine of the first thing, cos of the second thing, and then plus cos of the first thing times sine of the second thing. Good? How about this one? Sine 75. And this one's going to be a little bit more work in that here you have to think, I need something that adds to 75 that can be made from the special triangle. So it might be helpful to look at the special triangles in degrees this time, though we're going to want it in radians eventually. So let's write here 45, 45, 1 and 1, this is root 2. And then the other special triangle here, this one is 30, small angle, small side, big angle, big side, 2. Okay, so I need to make, using 45, 60, or 30, 75. Well, 30 and 45 both add together to make 75. So you can replace this with sine 30 plus sine 45. Oh, I'm sorry. Sine 30 plus 45 in the brackets. What I wrote made no sense. This is how it has to be, in brackets. So it's still the same question, still sine 75, but I broke it into 2 parts. And best of all, I broke it into 2 parts that I can use my formula sheet for, that same sine of a plus b. It's the sine of the first thing. I'm just looking at this formula here. Sine of 30, cosine of the second thing, 45, plus cosine of the first thing, cos of 30, sine of the second thing, 45. And now I can use my special triangle. Tells me, what's sine of 30? Go to 30, sine, opposite over hypotenuse, you get a half, times cos of 45. Special triangle, what's the cosine adjacent over hypotenuse? 1 over root 2. How about cos of 30? Let's put a plus there, don't forget. Cos of 30, that's adjacent over hypotenuse, root 3 over 2. And sine of 45, sine is opposite over hypotenuse, 1 over root 2. Well, we can simplify by top times top, bottom times bottom. We get 1 over 2 root 2 plus top times top, bottom times bottom. And we get root 3 over 2 root 2. And I'm running out of room here, so I'll put an equals beside. And since we have common denominator, we leave the denominator when we're adding. You just common denominator, the denominator stays the same. Add the numerator. We've got our answer. The answer of sine 75 with an exact value. Why do this? You could just punch in sine 75 on your calculator. The answer is because now you've got the exact value. You can get any amount of decimals from this. Let's look at the same thing, but doing it in radians. That is, in radians, we have sine of 5 pi over 12. If you wanted, you could quickly think about, what's 5 pi over 12 as degrees? 5 pi divided by 12. Well, pi is 180, so you could just go 5 times 180 divided by 12, and you get 75. Same question, but in radians. So you could think about it in degrees to help you solve, if that's helpful. Or you could think in terms of radians. So somewhere I need to draw special triangles. I think I'll do them in here because I got some space. Just want to redo these special triangles, but in radians. 45 is pi over 4. So that's pi over 4, pi over 4. And this special triangle, how do you make 60 degrees? That's pi over 3. Because 180 divided by 3 is 60. 180 divided by 6, that's 30. So here's my special triangles in radians. So the thing is, I need to make 5 pi over 12 using pi over 6, pi over 3, or pi over 4. The easiest way I know is to think about it like degrees. I know this is 75, so I need 30 and 45. So you could do it like that. Or you could also split it up into pieces that you know are going to be pi over 6, pi over 3, or pi over 4. That is, I can split 5 pi over 12 into 2 pi over 12 and 3 pi over 12. Again, feel free to convert it to degrees to make it easier. But here I'm going to go 5 pi over 12 is the same as 2 pi over 12 and 3 pi over 12. Why did I do that? Because I know 2 pi over 12 reduces to pi over 6. And 3 pi over 12, divide top and bottom by 3, gives you pi over 4. So now I've changed this sine expression, just like I did here, into 2 radians that exist in the special triangle. Which means I can use my special triangle now. I'm going to go, let's put a line here and a line here just to clearly separate it. I'm going to go up here and say, so that equals to the sine of, again, same formula from your formula sheet, sine of the first thing times cos of the second thing plus that formula sheet, cos of the first thing times sine of the second thing. You don't need brackets when you've got the words cos and sine there, but I'm going to need them now when it's numbers. So what's the sine of pi over 6? It's the same question as question 2, so I already know, but let's check. Pi over 6, sine is opposite over hypotenuse, that's 1 over 2. Cosine is pi over 4, so adjacent over hypotenuse, it's 1 over 2, plus cosine of pi over 6, cos pi over 6, that's root 3 over 2, and sine of pi over 4, opposite over hypotenuse. Now again, we've got those fractions, same work as before, top times top, bottom times bottom, plus top times top, bottom times bottom. And since they're common denominators, you can put the denominator as 1 and add the numerator. Question 1, 2, and 3 aren't too long, but question 4 is a bit longer. It says, if you've got sine of x is 4 over 5, and x is between 0 and pi over 2, that's quadrant 1, then, oh, and we know something else. Sine of y is negative 12 over 13, and the y is between 3 pi over 2 and 2 pi, so that's quadrant 4. Find cos x minus y. Okay, let's begin with sketches. Let's start by sketching the first one. I think we'll do them one at a time even. So here's x and y axis. Here we're in quadrant 1. So initial arm is here, rotate to here, and we know that this is, it might help to draw this triangle separately if you wanted. We know this triangle is made up of opposite 4 over hypotenuse 5. So what we really want here is not the related acute angle. We're not interested in that. What we're interested in is what's this missing side here. How do we find this missing side? Let's call it the b value. It's like a squared plus b squared equals c squared. That's what we're going to use. We're going to use the fact that we know in this right angle triangle that a squared plus b squared equals c squared. That is, we know that 4 squared plus b squared has to equal 5 squared. 4 squared is just 16. Feel free to use your calculator, won't judge. And 5 squared is 25. To get b squared by itself, we take away 16 both sides. And you get b squared is 25 take away 16, which is 9. And now how do you get rid of a square? Square root both sides. And when you square root 9, you can use a calculator. B is 3. So we can label this as 3. That helps you see. Why is that useful? Because now we already know, I'm going to write it down here, sine x is 4 over 5. But now we also know what cosine of x is. We should label this rotation here as x. This rotation x in quadrant 1, its rotation gives you sine x of 4 over 5, and its cos x would be adjacent, which is 3, over hypotenuse, 5. Now we know cos x. You'll see why that's going to be useful for us. But before I can show you, I have to show you how to do the second one, a rotation of y. So let's label the x and y axis, put an initial arm, and rotate into quadrant 4. Put a terminal arm, label this rotation y. Okay, so we know that in this triangle formed by the initial arm and terminal arm, sine is negative 12, so that's opposite, negative 12, over hypotenuse, 13. Now you could label this positive 12 because you know that in a triangle there's no negatives, but it won't matter, it'll go away. We're trying to find this side, let's call it beta as well, or b as well. And again, we know two sides in this right angle triangle, and we want to find this third side. So a squared plus b squared equals c squared. So what's a squared? Negative 12. Need brackets because there's a negative. And we'll solve for b squared, knowing that c squared is 13. Feel free to use your calculator. Negative 12 squared, 144. And 13 squared is 169. How do you get b squared by itself? Subtract 144, and you get b squared. What's 169 take away 144? You can do it in your head. Do it on a calculator, you get 25. And how do you get rid of a square? Square root. B is 5. So now we know not only is sine y, we know what it is already, negative 12 over 13, but cos of y, let's see, cosine. That's adjacent, the b, which we know is 5. So that's 5 over 13. The reason I like keeping the negative around here, even though it was a triangle, is that it helps me get the right sign here. You can check. In this quadrant, cosine should be positive. It is. In this quadrant, cosine should be positive. It is. So I've got the right signs on these. Why do all that work? Because I knew I was trying to solve cos of x minus y. On the formula sheet here, it's written a minus b. I'm going to change it to x minus y. That's the question. Ultimately, it's find cos of x minus y. So what's cos of x minus y? Well, let's use the formula sheet. I'll move this up just a little, make sure you can see it. So what's the cos of x minus y? It's cos of x minus y. So a minus b. So cos of x minus y is cos of x, cos of y, and then this one plus sine of x, sine of y. Do you see why we did all that work? It's because I knew I needed not just the sines, but I needed to know cos of x and cos of y, so I could solve this equation. Now I have them. So I can say, what's cos of x? 3/5 times the cos of y. What's the cos of y? 5 over 13. Plus sine of x. What's sine of x? I have it here, or I have it up there. 4/5 times the sine of y. What's sine of y? Negative 12 over 13. Now, we're multiplying fractions. So you get top times top, 15, over bottom times bottom, 65. And here, top times top, so plus, I'll still need a bracket because there's a negative here. 4 times 12, negative 48, over 5 times 13, which is 65. And then the last piece of work, what's 15 plus negative 48? That's just 15 take away 48. You can do it in your head. You can do it on a calculator. 15 take away 48 is negative 33. Now the answer is negative 33 over 65. And we're done.